Alright, in this video we're going to look at the absolute value inequalities. And at some point you're going to get absolute value bars, and you're going to have something inside. That something can be something like 2x plus 5, right? And they're going to tell you that it's less than some number. Well, how do you solve this? You need to turn this into an and compound inequality. You have to take what's inside the absolute value bars, right? So that 2x plus 5. And you have to say, especially when it's less than, okay? You have to put two like the same on the left and on the right. But on the right, you're going to put whatever this number is. So if this is 7, you're going to put a positive 7. And on this side, you're going to put a negative 7. Okay? Just reverse the sign. Okay? And then you solve it the same way you would solve a compound inequality. You would subtract 5 from both sides. And we're going to do an example next. But when it's less than, it becomes an and compound inequality. And you would have to review compound inequalities, okay, from the previous video, the previous class that we had. The videos are there. Now, if your absolute value, let's say of, for example, 2x plus 5, is greater than a number, when you have a greater than sign, then you're going to have an or compound inequality. That means you have to write two separate ones. You have to take what's inside the absolute value bars and just the same sign, greater than b. But then you also have to write another one, the 2x plus 5. This time you have to flip the sign and you have to change the sign of b, so negative b. Okay? And that's how we're going to solve them. So go ahead and write this down. We're going to do an example to illustrate this. So let's say that you're asked to solve for this one. The absolute value of 2x plus 1 is less than 5. Well, it's an absolute value. It's an absolute value inequality. And this is less than. And when you have a less than inequality, you have to change this into an and. That means you take what's inside the absolute value. You take that sign and you put it on both sides. On the right side, you take the 5. On the other side, you put the negative 5. See? Because it was a less than absolute value inequality. Now you go ahead and you solve. We're going to subtract 1 from both sides. Goes away from the middle. We're left with just the 2x in the middle. Since we only subtracted, the signs don't change. 5 minus 1 is 4. Negative 5 minus 1 is negative 6. Now we're solving for x, so we're going to divide by 2. And since we're dividing by a positive number, the signs don't change, right? That goes away in the middle. We have x is less than 4 divided by 2 is 2. And negative 6 divided by 2 is negative 3. Oops, the sign says. Now, remember I said how you read this. I always start from the middle. X has to be less than 2. Alright, so I'm going to put my two critical points. My two critical points are negative 3 and 2. There's no equal bar, so both of them are open. X is less than 2. So we're going to be this way. Remember, I read from the middle outwards. X is greater than negative 3. And if you don't want to read that, remember we can flip this, but you have to flip the x is greater than negative 3. So it goes this way, and they meet in the middle. And that's how you would graph it. And if you want domain notation for this one, it starts at negative 3, ends at 2, and they're both open, so they both get parentheses. Okay? Now what if we have the exact same problem, but instead of less than, we make it greater than? Now this is an absolute value problem, but it's greater than, which means this becomes an or compound inequality. So you have to write two separate ones, compound. You take the original one, you drop the absolute value bars, and you take the original one. It's greater than 5. And, or you take the original one, flip the sign, and you change the 5 to a negative 5. And then you solve them separately. Okay. Put the tablet down. So we're going to subtract 1 from both sides. That goes away. We're left with 2x greater than 5 minus 1 is 4. I'm going to divide by 2. X is greater than 2. Or, you solve this one, minus 1 minus 1. We bring down the 2x. Sign stays the same, negative 6 divided by 2. X is less than negative 3. Right? So you put down your 2 critical points. Critical point is negative 3 and 2. They're both open circles because there's no equal bar. See? And x is greater than 2. All the numbers that are bigger than 2 are going this way. X is less than negative 3. All the numbers that are smaller than negative 3 are going this way. Okay? And that's what it would look like on the number line in domain notation. Oops, sorry. Oh, I need to erase. Sorry, work. Here we go. Domain notation would be, this starts at negative infinity and it stops at negative 3, right? Negative infinity always gets parentheses. It's an open circle, so this gets parentheses. And remember the U for union. Starts at 2 and goes to positive infinity. Open circle, parentheses, infinity always gets parentheses. And that would be your domain notation. Okay? Sounds good.